And now it seems that Francisco Lopez has a very special announcement to do. So MIMo grows, simulating body and sensory development in a multimodal infant model. Please give him a warm applause for this announcement.
Yeah, thank you. Hope this is fine. Hi, everyone. My name is Francisco Lopez. I am a PhD student with Jochen Triesch in Frankfurt. And yeah, as Xavier said, I have a big announcement because MIMo grows. So have a look at this video. You will see a child that is moving around, playing with some toys, exploring his room, causing a bit of chaos. But the important thing is that this child is learning. Yeah? And the way that he's learning is both powered and constrained by his body. Thus, if we want to model infant development and learning, we need dedicated virtual and robotic embodiments. There has been some great work in this line with the iCub and the Nico robots, also the fetus simulator, and we've contributed with MIMo. For those of you who don't know him, MIMo is a multimodal infant model. He's a virtual simulation platform built on the Mujoko physics engine. He has the body of an 18-month-old infant, different sensory modalities including vision and touch, a few actuation models, and the main thing is that we can use MIMo to perform faster than real-time simulations that allow us to explore and hopefully explain infant development and learning. There will be a little MIMo talk tomorrow by Marco. Now, MIMo is good, but he's not perfect. Why? Because not all infants are 18 months old. So this is work that was done in Matej's lab here in Prague, where they retarget a real infant's motion into MIMo. And as you can see, the baby is touching its own body, but MIMo does not manage. Why? Because he doesn't have the same body. And this is a problem, and the solution was already given to us in the review of the very first MIMo paper at ICDL in 2022 by Daniela, who is also here. She said, I am wondering if it would be possible to model MIMo at different ages. I realize this is difficult to do with hardware, but on this platform, maybe it could be feasible. And well, it took us a couple of years, but finally we do this, sorry. Okay, so I'm very happy to introduce to you MIMo V2, a new updated version of our simulation platform, which now includes body growth and strength from birth to 2 years of age, foveated vision with developing vision acuity, also sensory motor delays, and some technical improvements, including inverse dynamics, a procedural environment generator, and code updates. So, for the rest of the talk, I'm going to go through each of these things, starting with the main thing, which is the body growth. So MIMo, you can see him there in his original 18-month-old body, is made of some basic geometries. And using data from the AnthroKids database, we scale each of these geometries to match the bodies of an average baby at each age. And now, in doing so, we also scale MIMo's weight, maintaining a constant density for each of his body parts. And as a result, you can see that MIMo between 0 and 24 months falls within one standard deviation of infants worldwide as measured by the World Health Organization. Now, an also interesting cool is that each of MIMo's body parts can be modified according to the requirements. So if you have a real baby and you want to model it with MIMo, you can use our default measurements as a starting point, but then modify, say, the hand so that it recreates the exact measurements of your baby. Okay, now let's look at the videos. So this is MIMo, how he was originally, and this is him growing from 0 to 24 months. The background is 1 meter, so from the perspective he looks quite big, but he's actually quite tiny. And another cool improvement, of course, is each of the body parts grows with his body. So you can see here MIMo's hand holding a €2 coin, but from birth, his hand is really quite small. And so we have all this growth, and this enables us, or will enable us, hopefully, to explore different behaviors and how these behaviors depend on the size and the constraints of the body. The next big thing is, of course, strength. So not only does MIMO's body grow, but also his strength grows accordingly. So we decided here to scale each of the actuator parameters according to the volume of the actuating body part, right? So as MIMO gets bigger, also he gets stronger. And as a sort of proof of concept experiment, what we did is we forced MIMO, let's say, to lift his head and his legs. And what we found is he's able to lift his head at 2 months of age and his legs at 4 months, more or less in line with real infants. Good. The next set of updates is for vision. So the first thing is foveation. So as you know, the retina has a higher density of receptors in the fovea than in the periphery. This translates into also cortical magnification. And we can model this quite simply with a logarithmic mapping, which has one parameter that we can sort of tune or select according to our requirements. So let's say that MIMO is sitting in front of some blocks. What he normally sees would be this sort of square, Cartesianly mapped image. But if we introduce this foveation, then we can sort of stretch the center and compress the periphery to capture at least some of the consequences of a real visual system. But as we just heard, another important aspect of vision during development is visual acuity. So you already saw the images that babies are born with a more blurry vision. Well, we can model this using a very simple contrast sensitivity function that acts as a smooth low-pass filter using some measurements of visual acuity for real infants. And as a result, MIMO's vision can now capture some of the consequences or some of the effects of this developing visual acuity. The next update involves sensory motor delays. So this is a consequence of the fact that there are finite travel speeds from the sensory periphery, when I touch something, to the brain where it's represented, and then back to the muscles. And we model this very simply with a first in, first out buffer. So whenever MIMO observes something, this is stored, but what it's returned to him is a sort of past observation. And we can, of course, control the size of this buffer according to what we want to study. And again, as a proof of concept, what we did is train MIMO on one of his example tasks, let's say, which is reaching for an object. Without delays, he has no problem. He reaches it very fast. This is just a simple sort of reinforcement learning experiment. But when we introduce sensory delays, then his behavior becomes a bit erratic. You can see on the bottom, he sort of moves his arm up before going down and touching of the object. Now, there are other improvements which I don't have time to get into, but just to mention them, we incorporated an inverse dynamics controller to move or rotate selected body parts. We also added a procedural environment generator with some random rooms, objects around him, etc. And in terms of the code, we moved to a more modular architecture that makes it easier to combine embodiments and scenes, and we updated compatibility with different libraries, in particular with Mujoko 3. And with that, I would just like to conclude. So in this work, we updated MIMO with physical growth, developing vision, sensory motor delays, and a few extra things. Now, we think that this new version of MIMO is a very promising tool for modeling and understanding early cognitive development. And we've been doing a lot of research ourselves, but we also want you to start using MIMO. And for this, we created the baby bench here at ICTL together with Matei, Xavier, and Jochen, of course. And so thank you already for those of you who joined the competition. We will get the winner announcements on Friday. I also wanted to mention that we have a postdoc in our lab who has been using MIMO, for example, to recreate the mobile paradigm. So I'm sure you have very cool experiments that you could use MIMO for. don't be shy, just approach us. And also we are already working towards the new version of MIMo, MIMo V3, which will incorporate audition, pain perception, and maybe something else. So if you have ideas, again, please just come to us. So with that, I would like to thank my collaborators, in particular Miles, who is in Frankfurt, and Marco, who is up there, who are shared first authors of this paper, of course MIMo. Thank all our affiliations and funding agencies, and thank you for your attention.
Thank you very much, Francisco. I see a question.
Sorry, before the question, quickly, Jochen asked me to mention that we have an opening PhD position, so if you know anyone who would be wanting to work on MIMo.
Thank you for this second announcement.
Did you update touch as well, or are you stretching the receptive field?
Sorry?
Did you update touch as well, so maybe adding more tactile sensors, or are you stretching the receptive fields of
No,
the
we
existing
did
ones?
not make any updates to the touch sensation, other than the fact that with MIMO's growth, yeah, the density of the sensors may change, but no, we didn't yet. We could incorporate it.
This question up there and up there. Choose. Fight.
I don't know. Thanks a lot. Well, you know, this is very interesting because, I mean, you can definitely simulate development. But in reality, in biological systems, the body grows along with the mind. So it's a sort of a, you know, they evolve together, they change together. So, in some sense, I mean, the size of the body changes, but it's not like a balloon that you blow into. You know, it's more different. You know, you get strength and so on and so forth, and the size. So I wonder how. I wonder how you can reconciliate. You know, try to reconcile this approach, which is body only, with a more biological approach, which is body and mind.
Yeah, thanks for the question. Let's say we provide the tool for half of the answer, and then it's up to you or ourselves to also incorporate the, let's say, the learning algorithms and the architectures that should also try to mimic the brain. But I mean, it sounds rough, but MIMo doesn't have a brain a priori, right? So, yeah, this is more of the method that can be used to model the body growth. Now it's up to all of us to, more or less, yes.
Thank you for your talk. I was wondering how you might think about incorporating lateralization into MIMO, so, you know, left-right differences and also bimanual coordination.
Yeah. So MIMO, let's say, is initialized as a tabula rasa kind of thing. So if there is any lateralization that comes prepackaged in a newborn infant, then MIMO does not have this, but he can learn it. So if maybe it's an interesting platform to test whether these things are learned or they are not. But I mean, a priori MIMO doesn't have this. One could somehow try to, let's say, add stronger right hand or left hand, something like this. But yeah, a priori he's very symmetric, and if anything, he should learn these preferences. Yeah.
Maybe last quick question, and quick in 10 seconds, please.
Very quick. Thanks, Francisco. When you say muscles,
yeah,
what do you mean?
So yes, MIMO has 3 actuations, so he can move with positional controllers. He also has some torque controllers, and then the muscle model is a simplified version of a work done in Munich that we incorporated in the journal paper version of MIMO recently. So basically, it still uses the torques, but with parameters that are defined as a muscle. Maybe we can go into the details a bit later, but yeah, thanks.
So Thank you again for all the questions, and thank you again, Francisco, for this good news.